Good morning everyone. Myself Dr. N. Pratyusha, Assistant Professor in Mathematics, Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. Today we will discuss about the Fourier transform part 1. This is under numerical methods and integral transform. This is the overview of today's presentation. First we will discuss about the introduction, that means what is Fourier transform and all, and applications, and we will discuss about the problem based on Fourier integrals. Okay, first we will discuss about the introduction. Here Fourier transform. Transform is the mathematical device which transforms one function to another functions, or it converts one state to another state. So the basic example of transformations are differentiation and integration. This is the basic well-known transformations. Okay, here the Fourier transform is a tool to break the waveform. The basic application of the basic Fourier transform are to break the signals, waveforms, and if you compose two signals to the one signal and divide the signals, so the Fourier transforms are decompose signal into a frequencies, and that can make it up also. Okay, the Fourier transform gives a unique and powerful way to view in the waveforms, and Fourier transforms are shows that any waveform can be rewritten as the sum of sinusoidal functions. Okay, this is the basic introduction of Fourier transforms, and next we will discuss about the applications. Fourier transforms has very variety applications in the real life. So it will be useful for aircraft and spacecraft guidance, where the signal will be used. In that concept, Fourier transforms are useful. So it will be useful in the digital signal processing, and it will be useful for medical imaging and oil and gas exploration, and it will be useful for the solving partial differentiations as well as ordinary differential equations. Okay, that are the basic applications of Fourier transforms. Okay, first we will discuss about the Fourier integral theorem. In your syllabus only we have statement. So I have written it as, it states that f of x equal to 1 by pi integral 0 to infinity integral minus infinity to infinity f of t cos p t minus x dt dp. Here we have doesn't have the proof, so that's why I only written the statement only. Okay, next based on this statement we will write the sine and cosine integral. So first we will see about the Fourier sine integral. So the Fourier sine integral is given by f of x equal to 2 by pi integral 0 to infinity sine px integral 0 to infinity f of t sine pt dt dp, and the Fourier cosine integral, in this formula we will put in the place of sine cosine, and in here also in the place of sine we will put cos. We will get the Fourier cosine integral. So this is the example of Fourier integral. So first example was using Fourier integral show that e power minus ax minus e power minus bx equal to some result is given. Actually Fourier integral will be solved based on result. Here in the result sin lambda x d lambda is given. That means in the right hand side the integrand is sine. So we will use Fourier sine integral formula. So in the previous slide we discussed about Fourier sine integral formula, right? So once again I am showing here f of x equal to 2 by pi integral 0 to infinity sine px integral 0 to infinity f of t sine pt dt dp. So here in the problem also they give a sine lambda x in the integrand at right hand side. So I am using Fourier sine integral, because in the right hand side the integrand contain sine term. So I already discussed about it. Fourier integrals will be based on the integrands at the present in the result. So here sine is present, that's why you are using Fourier sine integral. So the formula for Fourier integral is, Fourier sine integral is, what is the formula? F of x equal to 2 by pi integral 0 to infinity sine px integral 0 to infinity f of t sine pt dt dp. This is given, right? So this is the formula for Fourier sine integral. So here in the formula p terms are there and the result lambda terms are there. So I am replacing p with lambda. So replacing p by lambda. In the place of p I am substituting lambda. So the formula becomes f of x equal to 2 by pi integral 0 to infinity sine lambda x integral 0 to infinity f of t sine lambda t dt d lambda. So when I substituting p in the place of, when I substituting lambda in the place of p, I am getting formula as here. So now I will substitute f of t. In the problem, let here left hand side term I am taken as f of x. So f of x equal to e power minus ax minus e power minus bx. But in the formula f of t is given, right? So I will substitute t in place of x. I will get f of t equal to e power minus at minus e power minus bt. So now I substitute f of t in the above formula. So I will get f of x equal to, or f of t equal to 2 by pi integral 0 to infinity sine lambda x integral 0 to infinity, what is f of t? E power minus at minus e power minus bt, right? So I am substituting. So sine lambda t dt d lambda. First we will replace p with lambda. Next we substitute t in the place of in f of x. Then we get f of t equal to e power minus at minus e power minus bt. That f of t I will substitute in the Fourier sine integral formula. So now we are doing basic integration. So we will, so f of x equal to integral 0 to infinity two by pi integral 0 to infinity sine lambda x integral 0 to infinity, here e power minus at minus e power minus bt, sine lambda t is this, right? So I am multiplying. So we will get, and we are applying integration by parts. We will get integral 0 to infinity e power minus at sine lambda t dt minus integral 0 to infinity e power minus bt sine lambda t dt into d lambda. So we will integrate what we get, f of x equal to 2 by pi integral 0 to infinity sine lambda x. Here this is in the form of integral e power ax sine, no, I am writing here. So, integral, this is in the form of integral e power ax sine bx dx. So, the formula for e power ax sine bx dx is e power ax by a square plus b square a sine bx minus b cos bx. Suppose if you get e power ax cos bx means the formula will be e power ax by a square plus b square a into in the place of sine cos bx. For cos we will get plus. So, plus b sine bx. Okay. This is the formula for integral e power ax sine bx. Here in the place of a, minus a is there. In the place of b, lambda is there. So, we will substitute in the formula, we will get e power minus at by minus a whole square plus, in the place of b, lambda is there, right? So, lambda square minus a into sine lambda x minus, sine lambda t minus b, in the place of b, what is there? Lambda is right. So, lambda into cos lambda t. So, similarly, here in the place of a, minus b is there and in the place of b, lambda is there. So, we will get minus e power minus bt minus b whole square plus lambda square minus b sine lambda t minus lambda cos lambda t. So, just we are integrating, right? So, now we have to substitute limits also, right? So, limits are 0 to infinity. So, we will substitute the limit, we get f of x equal to 2 by pi integral 0 to infinity, here d lambda term also there. So, integral 0 to infinity sine lambda x. So, when we will substitute infinity, here e power minus at is there, right? So, we can write e power minus at as 1 by e power at, right? So, when we will substitute infinity, we will get 1 by infinity. So, 1 by infinity value as 0. When we will apply upper limit, the whole term will be 0 because e power minus at term is 0. 0 into anything is 0. So, 0 minus, when we are applying lower limit means we will put minus, right? So, minus 1 by e power 0. Anything power 0 value is 1, right? So, 1 by 1 is 1. So, this value is 1. So, 1 by a square plus lambda square minus a whole square means a square, right? So, a square plus lambda square minus a sine lambda into 0. Sine 0 value is 0 minus lambda into, will put in the place of t 0. So, cos 0. Cos 0 value is 1. If you want to remember means, we will write as sine 0 is 0, cos 0 is 1. So, similarly for next term, so minus, when we put infinity we will get 0, right? So, 0 minus of 1 by b square plus lambda square minus b into 0 minus lambda into 1. Here also we will substitute 0, sine 0 value is 0 and cos 0 value is 1. That only I am written here. So, f of x is e power minus ax minus e power minus bx, right? So, what we taken here, f of x equal to e power minus ax minus e power minus bx, right? That only I am writing here. So, e power minus ax minus e power minus bx. So, 2 by pi integral 0 to infinity sine lambda x. So, when we will multiply and we will apply the LCM, we get lambda into a square minus b square by lambda square plus a square into lambda square plus b square. D lambda term is there. So we will get e power minus ax minus e power minus bx equal to 2 into a square minus b square by pi into integral 0 to infinity sin lambda x by lambda square plus a square lambda square plus b square d lambda. This is the result they given, right? So 2 into b square minus a square by pi lambda into sin lambda x d lambda lambda square plus a square into lambda square plus b square. That only we get, right? Here minus. So first we take in the Fourier sine integral formula because in the result sine term is there. So Fourier sine integral formula is f of x equal to 2 by pi integral 0 to infinity sin px integral 0 to infinity f of t sin pt dt dp. So here in the result lambda is there, right? So we are replacing p with lambda. We will get formula as f of x equal to 2 by pi integral 0 to infinity sin lambda x integral 0 to infinity f of t sin lambda t dt d lambda. So f of x is the form in the problem e power minus ax minus e power minus bx. But in the formula f of t is there, right? So I am substituting in the place of x t. So I will get f of t equal to e power minus at minus e power minus bt. I am substituting in the formula f of t. So I am applying integration by parts. So I am multiplying e power minus at minus e power minus bt with sin lambda t into dt. So next I am applying integral e power minus ax sin bx formula. In this first term, in the place of a minus a is there, in the place of b lambda is there. I am substituting in the formula. In the second term, in the place of minus b is there and in the place of b lambda is there. So I am applying the limits. I get the final result, that is e power minus ax minus e power minus bx equal to minus 2 into a square minus b square is 2 into b square minus a square, right? So minus 2 into a square minus b square by pi into integral 0 to infinity sin lambda x divided by lambda square plus a square into lambda square plus b square into d lambda. This is the final result. So today's session we have discussed about the basic introduction of Fourier transforms and what is the applications of Fourier transform and Fourier integral formulas and one example about the Fourier integral. And next session we will discuss about the Fourier transforms. Okay, Fourier transforms we will discuss in the next session. Thank you.